No, 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 eso no tiene Excel, toca por el Excel de... el online. Se me había llegado contacto. Pero no llegó un correo informando que ya no es Excel en los computadores.
Yo sí lo vi. Y eso es lo mismo, ¿cierto? Que es lo mismo.
¿Ya lo viste? Sí.
Sí.
Y me imagino que toca entrar a la diapositiva y copiar esto. Award.
¿Y cuál? ¿A cuál te metiste?
En la última que estábamos viendo, Surfacing Materials. ¿O no? No, perdón. Base and Surface Materials.
Everybody there? Okay, so I'm going to type here subgrade, and I'm not going to venga. So I'm going to insert some cells here, and I'm going to say subgrade CBR. I'm going to put the data. We know that it's 5%. And we know what else we know? Base layer thickness, 475 millimeters. Spray seal module. Megapascal. And spray seal thickness, 40 millimeters. That's the data.
No.
So how much how much is the vertical module of the subgrade? It's going to be 10 times the CBR of the subgrade. I'm going to put here the units. How much is the horizontal?
The house.
The half of the
Half of that one. How much is Poisson's ratio? 0.45 always for subgrade. And the stress parameter is going to be EB divided 1 plus B.
Wait, what?
1 plus B.
I see.
yes, boy.
Creo que no, ¿no?
So,
So,
let's do
sorry, which one is the Poisson ratio? The Poisson ratio.
0.45. It's a,
Yeah, it's
it's a value. It's always 0.45 for the subgrade. Now we are going to do the base layer material. But the base layer material, remember that we need to divide it in 5 equal distance layers. So we have to divide it into 5 little sub layers. So I'm going to do top sub layer, layer 4, layer 3, layer 2, and layer 1. And I'm just going to insert an extra cell here, and I'm going to put thickness, so I can know how much is the thickness of each layer. Oh, very far.
Wait, what?
¿Tienes esta? ¿El estrés parámetro?
No.
Everybody there?
How you do the stress parameter?
Stress parameter is going to be the vertical module divided 1 plus Poisson's ratio.
The vertical module. Vertical module.
Divided by 5. Thickness is going to be, let me see what's the formula. Okay. Yeah.
Which page is that?
This is for the granular, for the subgrade, Poisson's ratio is 0.45. For the granular materials, Poisson's ratio is 0.35. But the stress parameter is EB divided 1 plus B.
About the Poisson's ratio,
Sorry? 0.45 for subgrades, always. And then 0.35 for granular materials, always. Okay, so now we know how much is the vertical module of the subgrade. We need to calculate the vertical module of the top sublayer. And then I'm going back to my PowerPoint, and I'm going to look how much is the vertical module of the top sublayer. It says it's going to be the minimum value of the indicated in the table 6.4 or 6.5, and the one using this equation that we have here. So, what are we going to do? We are going to use table 6.4 or 6.5. And I'm going to look to the tables. Table 6.4 says that is the suggested vertical module of top sublayer for normal standard base material, and table 6.5 is the suggested vertical module of top sublayer of high standard base material. So the difference between this one and this one is in this one is normal and this one is high standard. Which one is the material that we have? High. So I will be using table 6.5, right? So table 6.5. What else I need to know? I need to know the thickness of the overlying bound material. My overlying bound material is my spray seal. How much is the thickness of my spray seal?
100? 40
millimeters. And then it says how much is the module of your overlying bound material. My overlying bound material module is going to be 1,000. So I'm going to match 40 with 1,000. It was given.
500.
And then, yeah, 40 with 1,000. And I'm going to check that the suggested vertical module of the top sublayer is going to be 500. So option 1, okay, I'm going to write here vertical module top sublayer. Actually, and then I'm going to put option 1. I got 500 megapascal, right? And stable 6.5. Then option 2, I'm going to check what it's telling me. So is everybody there?
Abres paréntesis. 1 más el pollo de
Okay. Option 2, according to this, they are telling me, okay, for option 2, you are going to use this formula in which the EV of the top granular is going to be equal of the EV of the subbase, but in our case we have the subgrade, times 2 to the power of total granular thickness divided 125. I'm going to write that formula here. Let me see. Let's put this one here, this one here. So option 2 is going to be EV of the top sublayer is equal to EV of the subgrade to the power of, I forgot, total thickness divided 125. Total thickness divided 125. And then I'm going to put this as a subscript. And leave it like that, maybe? Okay. So if I use that formula, I'm going to say that the EV of the top sublayer is the EV of the subgrade to the power of the total thickness, which is 475 divided 125.
It's not 2 times?
Oh yes, yes. Where was it? 2 times. Thank you. Where is it? 2 times 2 to the power of whatever. Times, no, okay, times 2. To the power of the total thickness. Yes, thank you. ED times 2 to the power of that megapascal. And I got that my vertical module with that formula is 696.44. You got the same? So I got 696.44. Everybody? You said no.
See the formula again?
What given? 40. You got it? Okay, so I got 696 and 500. And then I refer to the table and they tell me, you are going to use the minimum of the values between the value of the table and the equation, and that will be your vertical module. So I'm going back here, and which one is the smallest? 500. So my vertical module is going to be the minimum of those two values, which is 500. So 500 megapaths, so if you know that one, then you can calculate the horizontal module. That is going to be half. You are going to be able to say Poisson's ratio is always 0.35 for the granular materials, and the stress parameter, you already have the formula.
Okay.
Okay.
So this one is half, but you already have the formula, right? So control copy and paste the formula. This one is 0.35 always for granular materials, and this one, you already have the formula.
Ok, son las mismas fórmulas. Es esta.
No, we don't use that information, but because we divided in 5 equidistance layers, I just wanted to show that it was like the same thickness. But we actually don't use them.
Esta es la misma que esta.
¿Cuál es la de 250?
Es la misma, ¿no? Entonces, o puedes abrirla. Pero tú
Ah,
le-
ya, 250,
Ajá.
ya.
Esa sí es.
No, esta no es.
No, porque es un valor.
La de Poisson ratio. A ver.
¿Esto es lo mismo? Sí.
Is 0.35. ¿De dónde puto valor es 0.35?
¿Cuál? ¿Este?
El de Poisson ratio.
Creo que ese es un valor. O sea, siempre es el mismo. Para...
Ah, 0.35. ¿Segurito?
Creo. No.
¿De dónde sacamos los valores de Poisson ratio? Están acá. No.
Espérame un segundo.
Espera. Oh, listo. Ah, míralo. Sí, 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 sí. Míralo acá. Ya. Dale. Y el de estrés para mostrar.
Es lo mismo.
Este.
Es lo mismo.
Listo, ya está. Y eso, y hoy en todos, pues.
All good? Everybody?
Esos 95 donde dice
Sí, creo que son.
Poner los del layer 4, del layer 3, del layer 2, del layer 1. De la fórmula de los layers. ¿Qué es esto? 2, 3, 4, ¿no? Es diferente.
Pero...
Es diferente. Porque es al cuadrado. ¿Cuál es? ¿Cuál
Now
fórmula?
the next thing that we are going to do is to calculate the ratio of moduli. Ratio of moduli is telling us that it's going to be the EV of the top divided by the EV of the subgrade to the power of 1/5.
Y después de...
So I'm going to write down here ratio
Dividido ese.
of moduli.
Dime qué dijo.
porque sabes que está alineado tus valores, ¿no?
I have to write this.
Yo estoy viendo aquí, por favor.
No lo hagas, yo no te digo.
EV of the top divided EV of the subgrade, everything to the power of 1/5. that ratio of moduli R is going to be equal to EV of the top divided EV of the subgrade to the power of 1/5.
¿Qué? Me perdí.
All good?
¿Eso? ¿Dónde está?
No, pero no debes moverte hacia el lado, debes seguir siendo el Excel. No de.
Sí, pero es que el Excel.
So, now I know my ratio of moduli. Now I need to know
Sí, no te copia esto. Copia esto.
Now I want to know how much is the vertical module of my layer 4. And the vertical module of my layer 4 is going to be the vertical module of the subgrade times R to the power of 4. So I'm going to do the vertical module of the subgrade times R to the power of 4. And I got 315.
Vale, entonces está dividido en tres. Dividido en este, ¿no?
No, o sea, sí, sí.
Pero no se supone, es una pregunta.
Es un 5 que está en la fórmula.
All good? So horizontal module is the same. Let's do that at the end. So how much will be the vertical module of the layer 3? Is going to be, yeah. Okay, I'm going to put money symbol here. I'm going to drag to the side. And then this one is going to be to the power of 3. Okay, I click something. I want this one. This one will be to the power of 3. This one will be to the power of 2. This one will be to the power of 1. This one, same, same, same. You got same number? Got the same?
Podrías darle clic. Miriam, podrías darle clic en el layer 3 en 199.
No, pero Pavement está mal.
Qué hueva, no me coloqué. Listo, ya. Ahora sí ya me dio. ¿Ya lo ves?
Sí, la primera fila.
Listo. 147, 93, 58.
Espera, a ver que yo no.
¿Dónde está?
En la segunda.
¿En 250?
Sí, es lo mismo. Y lo arrastras, ¿cierto?
Tienes que ponerle, le colocaste aquí. Así, lo arrastras. O sea, esta parte tiene que cambiar, esto no lo tienes que regular. Que te corre de arriba y te sigue corriendo de abajo. ¿Sí me entiendes? O sea, no te puedes regularlo con el celular. Porque es que te está cogiendo este valor para todo y tú necesitas que te coja este valor. No necesitas que te ponga
Tienes que
Agree?
cambiarle
You got it?
y ahora los de abajo arrastras.
Solo la arrastras.
Ajá.
Ujú.
Y los de abajo arrastras.
¿Esto?
Ajá. Y después lo llevas. a todos, a mitad del color, a todos, y disminuyes hasta que te quede más chiquitico. Ahí está perfecto.
Tenemos un segundo sentido. Pero mira, este es el uso de...
Eso iba a mirar si es el último de pero no me acuerdo.
Sí, ¿verdad? A ver,
¿Alguno sabe cómo se coloca la letra chiquita en este Excel?
Así voy a ir.
Y después el número que es...
Everybody okay there? Okay. So this is